Welcome back. In the last section, you saw how we can make the computer appear to make decisions. That's one of the very exciting things computers can do, but it's not the only one. The other main thing that computers do so well is repeat things. And in this section, we'll start to look at how certain kinds of repetition are done. In particular, we're looking at a style of repetition that's about counting. And you can see by the page in front of you that we have the ability to do several kinds of counting. So we'll take a look. We'll click on the button, the Count to 10 button, and watch to see what happens. Ooh, it counted to 10. I know, it's not that exciting, but go with me here. Okay, so it counted to 10. Now let's take a look at the next button, the Count backwards. That counts backwards from 10 to 1, and we can even count by fives. 5, 10, 15, 20, 25. And so on. Well, this may seem like a stupid pet trick, but it turns out to be a very useful thing. A lot of times we'll have a list of things and we'll want to go through that list. And so there's a particular kind of looping behavior that's wonderful when we know how many times we want to do something. And that thing is called the for loop. So we're going to begin by looking at this very basic count to 10 behavior and see how that works. As always, Control-U, Command-U, whatever you use to look at the code, and you'll see there's interesting stuff happening. Once again, we begin by looking at the form, which is very straightforward. It has 3 buttons. Each button calls a separate function, and that's useful because now we can look at these functions in isolation to see what they do. And there's an output area that allows me to finally just see the output. There's one more interesting thing about this HTML page. If you look at line 41, there's something unique here. We say body. Well, that's not unusual, but the body has an event handler. We're used to buttons having the onClick event handler, but the body has what's called an onLoad event handler. And what this means is, well, when the body is finished loading, then I want you to run a particular function. And we're going to run the init function. Okay, this is a very common thing. We use it in most of our games because most games involve some sort of an initialization step. Most of the time in gaming, we want to set things up before we allow the user to play. So we'll very frequently have some kind of an init function. Now you take a look inside the code and you can see that's exactly what's happening. First thing is, before we do any functions, I've defined output. Now, up till now, we tend to define functions only, or variables only inside functions. And that's typical where they belong. Because, see, a variable only has meaning inside a function, you don't have to keep track of it. Every once in a while, you'll have a very special variable like output, which is used by a lot of different functions. In that case, I'm going to create that variable outside of any function calls so I can use it among other functions. Does that make sense? So this variable is available to the entire page. You don't want to do that too often because you're now required to keep track of its behavior. But for very, very important elements like the output element here, it's an okay solution. Now we look at the init function, and it doesn't surprise you what the init does. Since output is important, what does init do? It initializes output. That's not surprising. Typically, what will an init function do? It will initialize things, thus the misleading name. Okay, so we got that. Now that's useful because if I do it once in init, I don't have to do it in all the other functions. So that's a really handy thing. Now we'll take a look at the count function, and that's the one that counted from 1 to 10. Let's take a look at what it does. The first thing you can see in line 17 is that it simply sets outputs inner HTML to blank. That way, whatever was in there before, it's now empty, so I can write some new stuff on there. All right, following that, that's good. Now what would we do? Well, once we've cleared up the output, now we want to do something multiple times. The interesting thing here is that we've only got one piece of code that actually writes anything to output. But what happens is that thing happens 10 times. Oh, let's see what's happening. We have the keyword for. That means I'm setting up a special kind of looping behavior. A for loop is something that's going to happen several times. Now, any kind of loop has certain things in common. Loops usually are based on some sort of a variable. See, it's easy to make the computer repeat. What's hard to do is get the computer to repeat exactly the way you want, to go when you want it to go and to stop when you want it to stop. So in order to do that, we think of a number of things. First thing is, what variable controls the loop? Typically, there's one primary variable that controls the loop. Some programmers will call that a sentry variable. In my case, well, I is the sentry variable. I is just sort of the tradition. When you don't have another name for an integer, you just call it I. Kind of comes from math. Okay, we can do that. So I starts out as 1. That's what's happening here. I gets 1. All right, so the first piece of the for loop inside the parentheses is we're initializing the sentry variable. We're telling the sentry, hey, where do you start? You follow me? Okay, now take a look at this part. This looks like a condition. I is less than or equal to 10. Okay, now I told you about this kind, right? This is another condition. Oh, since it's numeric, we can check that it's less than or equal to some value. So if this section tells me how I starts, this tells me how I stops. So the loop keeps going as long as I is less than or equal to 10, but as soon as this condition is not true, the loop will exit. So we initialize the sentry, give it a starting place. We explain a condition for repeating, which gives us a stopping place. And then finally, somehow, we change the variable. That's what this I++ does. I++. Okay, I++ is relatively simple. What it really is the same thing as I gets I plus 1. Let me take you back over to the console and we'll try some experiments with this. So we'll say I gets 0. Okay, I gets I plus 1. In algebra, that would be freaky, wouldn't it? But we're not saying I is equal to I plus 1. We're saying take the initial value of I, add 1 to it. Now we look at I and it's a 1. You get that? Okay, well there's another shorthand way of saying that. I plus equal 1. That's another way of saying, hey, add 1 to I, because it's a relatively common thing to do. We can do that with other values too. I plus equal 5. I's value is now 7. But since it's so common to add 1, there's one more shortcut for that, and that's I plus plus. And we'll take a look at that, and now the value of I is 8. How come it said 7 first? Because that's a post-increment operator. Do you care? No, you don't. So what we're really saying is I++ allows us to add 1 to I. The really handy thing to be able to do. It's very common. All right, so let's take a look again at what's happening here. In a for loop, we're saying that you first have to have a sentry variable, and then you need to know 3 things about it. How does it start? How does it end? How does it change? You know those things, you're going to have a loop that behaves well. Does that make sense? And in a for loop, all these things are usually numbers. How does it start? What's the initial numeric integer value of I? How does it end? What's the condition? As long as this condition is true, we stay in there. As soon as it's not true, we get out. And then, how does it change? Every time through the loop, this will happen to I. We're going to add 1 to it. Okay, let's walk through it. On my first pass, I's value becomes 1. Output.inner HTML I plus a BR. That's going to print a 1 on the screen and a BR tag. The for loop is over, so it comes back here. I++. Okay, I is now 2. Is I less than or equal to 10? Yeah, it is. So what do? The loop again. I is now 2, so we'll print out a 2, 3, 4, 5, 6, 7. We get to 10. Okay, print it out. I is at 10. Now we come back here, increment, 11. I less than or equal to 10? Not anymore. We're out of Dodge. We end the loop. We end the function. So that's how for loops work. Does that make sense? It's all about the sentry variable. How's it start? How's it end? How's it change? You keep track of this, and your loops will work just great. Sound good? Okay, so let's look at a variation. What if we want to count backwards? Okay, this one does the same thing. It goes 10, 9, 8, 7, 6. So it's the same sort of deal, but some of the details are different. Take a look. It's still the same thing. We still have I, but how does it start? Now it starts with 10. How does it end? Well, keep going as long as I is greater than 0. And then how does it change? I minus minus. You guessed it. What does I minus minus mean? Subtract 1 from I. All right, very nice, very nice. So do you see how this one would work? This one's going to start out at 10, and then it's going to 9, 8, 7. Eventually, it gets to 1, It'll print it out, and then it'll get to 0. Is 0 greater than 0? Nope, so we're out. And then we leave. Make sense? Okay, one more example. How about counting by 5s? You're beginning to see this, right? 5, 10, 15, 20. It's almost the same. This time, we initialize I to 5. That's how it starts. I is less than or equal to 25. Stick around as long as we're 25 or less. I plus equal 5. Add 5 each time. If this isn't making sense to you, you need to write these yourself and experiment. Change all these values and see if you can understand how it's all working. Be careful. If the number is going down, you're going to have a different kind of condition. If the number's up, you're going to have a less than condition typically. If the number's going down, you're going to have a greater than condition. This condition indicates how we stay in the loop, but of course the inverse of that is how we get out. So that is the for loop, and it's the basic foundation of all repeating behavior in a computer program. Pretty cool, huh? Yeah, pretty cool. Come back and I'll show you another form of loop that's even more powerful. See you then.